Good afternoon, ladies and gentlemen. Take your seats, please. Thank you very much. Did you enjoy your lunch? Yes, it's a very good lunch, and I was right about the mushroom vol au vents, wasn't I? Yeah, they are the business. Thanks very much for that. There was a little warm up upstairs, but it's a lot cooler down here, so you'll enjoy our next three speakers, I'm sure. Our first speaker is Alex Radu, VP Product Adoption Lead, Cloud Center of Excellence for JP Morgan Chase & Co. And Alex is going to talk about, well, she said she's going to talk you through some easy to implement examples of why you need a Cloud Center of Excellence. So, Alex, over to you.
Great. I appreciate the applause, but I think we should leave them for the end, if you do enjoy the session. I appreciate the encouragement, though. So before I get started, I do have a disclaimer. All views expressed in this presentation are my own and not my employer's. Now that we got that out of the way, today we're going to talk about three things in particular about Cloud Center of Excellence. What a Cloud Center of Excellence, or CCOE, is, how you can start building one, and why you might want one, and some examples of how a Cloud Center of Excellence can uplift your cloud strategy and your implementation and enablement. So we're going to start with the what. And as some of you might have heard, we've chatted upstairs in the heat. I started with, we're going to begin with a Star Wars metaphor. So I hope there are some Star Wars fans in the audience. A lot of people have a lot of misconceptions about what a Cloud Center of Excellence is. And I thought really long and hard about how I could explain this so that anyone can understand it, whether you do have a CCO in your company, whether you don't, whether you're thinking about starting one. And the way that I like to explain it is, people often see the CCOE as the most sage of the Jedis, or Yoda, and they think like it's the be-all, the do-all, the end-all of your cloud organization. They also sometimes might think that it's only for experts because it's a center of excellence. And also they think that, it's there to be the central governance or control entity. And that couldn't be further away from the truth. So instead, it's more like the alliance. So it should be more like a joint alliance of people that are there to support, enable, and further your cloud goals, your strategy. They should own and execute on your cloud strategy, but they should also drive collaboration and best practices in your organization. They should look at minimizing costs, taking advantage of discounts, of how you can reuse your patterns, your code, how you deploy, what services you use. So they should be there to streamline and improve how you adopt and migrate to cloud. They shouldn't be there to tell you what ST tier to use. They could potentially help you if you really need help with that, but they shouldn't be there to tell you you can only use this type of instance or you should only use the service. That shouldn't be their primary goal. So we're going to go back to 2016, and this was the earliest definition of a CCOE that I could find. And it happens that it was on an AWS blog, and it happens that it was written by Stephen Orban, that's not at AWS anymore, but at the time, he wrote this blog. And he gave a definition that at the time was accurate, but over time, it's kind of changed a little bit. And specifically, the part that I think is not as true today is around kind of like the operations side, because it's not only about the operations, it's also about a whole load of other things. Gartner researched, and they looked at how many organizations and companies will be adopting cloud by 2027, and they now predict that that's going to be about 50% of all enterprises will actually leverage some form of cloud by 2027. And that means that it's now so pervasive, and it's moving so fast, and everyone is trying to adopt and migrate to it, that actually it's not really only about operations. There are a lot of other things. So, before we move on to the how, do have a thing I need to say. If you think that you can go and take a blueprint from a company and implement their CCOE structure in yours, I do want to warn you that that's probably not going to be very effective for your company. There is no one size fits all. There are frameworks, there are ideas, there are ways that you can implement it, but ultimately, It will only work if you do the work. And you should discover what works for you in doing that work. And that implies looking at where you are in your migration journey or your adoption journey, how mature your organization is, how big your organization is, what type of skills you have, what type of people you have, what type of people you need to bring together, and how you should structure your CCOE or your cloud organization going forward. The other thing is, the CCOE is called a lot of different things. It might be a center of cloud knowledge, it might be cloud champions. People have different names for it, but ultimately it's about bringing the people that can help and know most about cloud in your organization together to make informed strategic decisions about your cloud future. Now, I tried to simplify deciding what CCOE to go for. This is by no means exhaustive, but this is the most prevalent kind of like structure that they can take. So the first one's a centralized organizational structure, and usually this works for smaller businesses where you don't have that many organizational units or teams, and you can actually have just one central organization that will be your CCOE to inform your patterns, your architectures, your governance, your guardrails, your like FinOps practices, optimizations. So that's kind of like the beginning of your maturity journey, or if you're a smaller size company. Now, if you are a bigger company, you might look at a decentralized model, where you have a CCOE embedded into each of your organizational units. And that means that you gain that advantage of knowing exactly what your teams need, knowing exactly what you need to build for them to use cloud in the most effective way. But at the same time, you don't really have that connectivity between the different CCOEs to drive that holistic like enterprise vision and strategy. So everyone's doing things in their own way. Sometimes they might be doing the same things, but no one talks to each other. So you don't actually know. And you're probably losing out on a lot of money, a lot of optimization, a lot of speed, because you don't talk to each other. So that's where the third model comes in, which is a semi-centralized model. It also happens to be the model that we use in our company, where you have a cloud cell, which is like your own CCOE organization within your organizational unit, but you then have a central CCOE that brings them all together and forms the Cloud Alliance. And that's really good in really big companies, because you not only have the individual cells meeting the needs of your teams in those organizations, but you also bring them all together to learn from each other, share, build better frameworks, build better guardrails together, and making sure that they're all leveraging the best information that they have. So, like I said, this is what we use. It does work better for like bigger, more established companies that are further in their cloud journey, mainly because you already know who the key people in your organizations are that are focusing on your cloud excellence, and you can bring them all together to share and kind of like start standardizing everything across. There will be discrepancies. There will be things that some do that others don't, but that doesn't mean they shouldn't know. If someone else has built a pattern before them, they could go and reuse that instead of building a new one, but also they can contribute back to the pattern to improve it if that's the case when they adopt it. So, in terms of a team, this is an example of what a team can look like, and you'd have your central CCOE team that's mainly there for the strategy, governance, structure side to kind of like steer the ship together. But then in your cloud cells, you can actually have some different types of roles. And that might be things like compliance, it might be things like security, you might have information security managers in there, you might have FinOps managers that look at your cost optimization and your spending, you might have like your adoption and engagement side of like your team, you also might have your cloud platform engineers. So they all reside closer to the customers in the business, but they all come together under like the holistic CCOE structure. In terms of how you get the right team, you can't really go through this process if you don't have people that meet at least some or maybe more than half of these traits. For someone to decide to be an enabler, and decide to spend their time driving others to adopt or migrate to cloud, they do need to be a certain type of person. However, you also need to think about how do you create and feed into that pipeline of talent, because people like this are really hard to come by. And if we don't help make them, we won't have them. And it'll be very hard to get anyone that has that mindset to enable you to move your cloud journey forward. So the other thing that I want to emphasize is not everyone in a cloud center of excellence will be a cloud engineer or a cloud engineering expert. Not everyone will be a cloud veteran. There are a lot of other people that are really good at a lot of other things, like security, like financials, finance managers, a lot of other training, learning. They're not just cloud, but they are all focused on cloud. So I tried to summarize in 5 steps what you need so you can build a CCOE if you don't already have one. The first part, and this is the hardest, is getting the data and understanding what is that you're trying to build with your cloud center of excellence. What is it that you're actually trying to get from it, and why do you need it? Because if you don't know why you want it, you're probably not going to build it very well. And also try to look at, based on your current adoption and migration status, what is it that you need to go to the next level? And this might be talking to your consultants, talking to your vendors, talking to your partners, and understanding, okay, what does it mean to get to that next level? Or like, how can you help me figure out what level I'm at? And then go and like move forward to, okay, I know where I'm at, and I have an idea where I need to go, and now I need to build that team, or get those people that I already have together as a team to move me forward. Second part, and this is the tricky one, you need to have leadership that believes in your idea and in you, and that believes that a CCOE is a good idea. It doesn't have to be from the beginning. You can also go in and show them and demonstrate to them how this would help you. But again, if you haven't done that first part really well, it's going to be really hard to do that, because they will not take any BS. And if you don't have a strong case, they will just dismiss it and be like, yeah, we don't need this. The third one, obviously, you need to build a strong, diverse team. Again, it doesn't have to be new people. You probably already have these people in your organization. They're probably the people that are the most passionate and the most willing to drive your cloud strategy forward, but it's all about getting them together and getting them to talk to each other and getting them to work together to improve what you already do in cloud. And then in the fourth step, you want to start thinking about environments, processes, governance, compliance. So depending on what industry you're in and what your requirements are, the next step, when you've already kind of established your team, you have the buy-in, you have the goals, you know what your next steps are actually starting to implement these in real life in your environments and in your infrastructure. And then the fifth step would be to start reusing, reorganizing, and enabling. So basically using all of that expertise, all of those people together to actually start contributing and leveraging each other's knowledge and experience, as opposed to just rebuilding everything from scratch every single time someone gets an AWS account and they want to deploy an application on it. Cool. So now we're getting to the really interesting part, and that's the why. And this is where the examples come in. And you might be thinking, well, it's fine, I'm fine, everything's fine, I don't really need a CCOE. But I really wanted to bring to life what it actually means and how that looks like in real life. So we have a few examples, 5, that we're going to go through. And I've tried to consolidate how things look before you have a CCOE and after you get a CCOE, and how some of the bumps and some of the issues that you might encounter without that central governance and strategy structure could be improved by getting teams organized as a CCOE. So we're talking about new products and services or features. This might be in terms of, getting an application to enable a new service for your company to use. They might be just focused on what we need because we're special. They might want to have like the end-to-end enablement because no one else can provide anything to them. And obviously they're going to be engaging on a one-on-one basis with your vendors, with your contractors to get that solution done. However, if you did have a CCOE, you would then have to bring this and think about, okay, we need the service. There are other people that need the service. We're going to look at the best service to satisfy the needs that also makes financial sense, but that also meets the needs of all of our teams. You then can have like a cross-product solution request because actually they didn't just want a service, they wanted to do a very specific thing. And to get to that thing, they probably need 2 or 3 more services or components. And then you also have the opportunity to test it with a lot more people and get a lot more feedback and improve it a lot more before you go GA. Next part, cloud fluency. This is something that's been on a lot of companies' minds. How do we get people to understand what this cloud thing is? In smaller places where you maybe don't have a central cloud learning team or a central cloud learning center of excellence, they actually are team organization managed. So someone goes to their manager and says, hey, I want to do a certification. Cool, awesome, awesome. Go and do the certification. However, with a CCOE, you then have like more processes around this where you're thinking, okay, we want to get 500 people certified. We're going to talk to our cloud vendor for that certification, and we're going to get a discount. We're going to commit to getting 500 licenses for them to do the training, take their certification, and you're actually going to pay half, maybe less than that, depending on the size of your organization. Cloud app development. Usually, it's pretty complex, doesn't happen overnight. Your speed to market can be reduced because you have to go through the whole process of architecting, designing, developing, testing with your teams, and everyone makes their own, because why would I use something else that someone told me that is really, really good to use and it fits my use case? With the CCOE, generally, you will have patterns. You will build patterns that can be reused across your applications, across your teams, that meet a certain use case demand. Not everything will be a pattern, but 90% of the things that you're going to be building will be a pattern. And the better your patterns, the better the team creating those patterns, the faster you're going to be able to go through that process with your teams. And we're going to FinOps. So now that a lot of more companies are maturing in their cloud usage, they're realizing that they could actually optimize in a lot of places to save money. On top of that, they also, if they happen to have I want to do something in cloud, I'm going to go and get an account. Now you have like 100 distributed accounts that you have absolutely no visibility over because they're all individual accounts. If you do get an organizational account, and usually centers of excellence and FinOps teams will recommend that because you then can see the breakdown of your usage, you can see the breakdown of your costs, you can see where you can optimize, where you can turn stuff off. So if you have that visibility across your organization and you have a central point where it all comes to, they can actually help you save money. Yes, the cloud can save money, but only if you do it right. So this offers you that second layer of, okay, you can save money even more if you do these 5 things. And here's some tools to do that. Last part, compliance and security. Again, if you're vending accounts from a central place, you can then create security guardrails where it can actually help you terminate some instances. If you have like a password rotation policy, it can help you actually monitor those risks and remediate those risks without the application teams having to do anything. But to do that, you need to have a central organization actually looking at those things and implementing them. So these are 6 of the reasons why you should build a Cloud Center of Excellence. And with that, I'm all done. Thank you so much.
Thank you. Thank you very much, Alex. Our next speaker is Guy Templeton, Principal Software Engineer for Skyscanner. And Guy's going to be talking about the benefits and challenges that containers have brought. So, Guy, over to you.
Thank you very much. I'm going to talk about evolution of containers and cluster management. Start with a bit of awkward audience interaction. Who's running containers in production? Cool. And Kubernetes as a container management system? Cool. Awesome. as you will discover, those are my biases. So yeah, I'm a principal software engineer at Skyscanner, where I'm focused mainly on shared container platforms, as well as continuous deployment functionality, to the rest, providing that to the rest of the business, allowing them to deliver, focus on delivering features reliably to our travellers and partners. However, I have another hat that I wear, which is that I'm also a co-chair of Kubernetes Autoscaling Special Interest Group. Hence, a lot of the references I'm making here will probably be to Kubernetes. So containers, then container orchestration, then a bit about the problems and the potential future that is going to result in. So containers, they came with the promise of all your developers will be able to reliably build and publish what they'll run on their local machine. Same thing, it's just a different configuration when you're running it in prod or a pre-prod environment, whatever it might be. Build and test it locally with Docker Compose, for example. You can set up your CI/CD system, push and automatically build and publish that, trigger a deploy of those new containers that you've published. And then you create a new version of your software or update your dependencies, you just publish a new image, rather than copying it onto an existing running machine, as I have previously done. However, this doesn't actually abstract all of the developers' problems and create some new ones. So where does this service actually run? If I'm a developer used to dealing with a VM, do I now need to manage the VM and manage the container runtime on that machine? Or do I use a container orchestration layer? What if my deploy pipeline fails? And how do I know if my service is running as expected? What's my observability around that? Because it may well be completely different to how you were used to monitoring your software. And these are some of the problems that container orchestration software started solving. So there were a number of solutions started appearing around the same time: ECS, Docker Swarm, Kubernetes, etc. And there are still some available other than Kubernetes. I'm going to quickly cover Skyscanner's journey through these different, through a number of different architectures, sort of talk you through the challenges we faced as we went along the journey of adopting containers in Skyscanner, and container orchestration, and how we provided that as a service to the rest of the business, and maybe you can avoid making some of the same mistakes that we made. So we started off by going, oh, that's cool, we've got continuous integration for you. We will let you create and run your own ECS cluster in AWS as an app team. So here we've got two different ECS clusters for Service Team A, Service Team B. Service Team A has two different services, they can auto-scale, etc. Service Team B only has one service. And we're running an ELB in front of all of them. There's obviously a pile of wastage here. Like, we're not actually delivering a lot of the promise of containers because we're not properly bin packing. Service Team B is running an entire ECS cluster for maybe just one container, and maybe they don't know what size that container might be, so they end up not really bin packing that a huge amount. But more importantly, every service team here was left to figure out a way of deploying and maintaining an ECS cluster, whether through CloudFormation or Terraform or whatever they might be. So there was a pile of inconsistency, as well as it being outside the core skill set of most of our developers. This was fairly early in our journey onto AWS. Most developers hadn't really developed the sort of skill set at this point. I'm not saying this model can never work. I know a few companies where an orchestration cluster per team, in this case Kubernetes, works really well. They spin up an entire AWS account, give them a cluster and go, that's now yours. However, I think most of the companies I've talked to that make that work are of a larger scale, where they have a cloud center of excellence and they can spread this knowledge. They can have people embedded within the teams that actually know how to run these things. Skyscanner scale with smaller teams, that doesn't really work for us. So we decided to consolidate this, start getting the bin packing benefits, have a single team responsible for running and maintaining and scaling that cluster up and down as we have traveller demand searching for flights. We still have the single ELB per service here, but we are getting that bin packing. we also used this opportunity to build in a carrot for our developers to move to this by saying, we give you a consolidated monitoring experience here. We can give you unified metrics so that you know how all your services are running in terms of HTTP response codes, latencies, in a single standardized method by baking that into the base images of the cluster. And then I'm going to slightly skip over our journey from ECS to Kubernetes. We basically decided that Kubernetes had, by this point, gained so much developer mindshare. All the SaaS platforms that we were talking to and wanting to use were saying, oh, we've got a Kubernetes implementation, we'll think about ECS or Docker Swarm or whatever it might be at some point in the future. So it was becoming a constraint in our ability to adopt certain technologies. But we moved from a single cluster to multiple clusters. So we got big clusters that were running in a single AWS region, but they were sort of they were getting unwieldy, they were getting a bit too big to fail. However, the way we'd done it meant that actually we hadn't really increased our resiliency here. We'd sort of helped with our management of the control plane of clusters, Kubernetes clusters. But in this case, an outage in cluster 2 means that service A can't talk to service B, and it ends up actually being a global outage still. So this model, despite the fact we'd moved from 1 cluster per region to 2 clusters per region, wasn't actually a resilience benefit to our travelers, so we still had instances where a single cluster failed. We need to move traffic out of that entire region, cross to another region, associated latency, degraded traveler experience. So we then cribbed off AWS's workbook and decided to move to a cellular architecture. So we wanted to achieve a few things. We didn't want the old model of an ELB per service. We didn't want services to have to know where they were where their dependencies lived. They just needed to know, I'm service foo, I want to talk to service bar, and let the infrastructure take care of that. We wanted failover between clusters, services or clusters failed. And we also wanted to follow AWS's resiliency model of, we wanted to be able to tolerate the outage of an entire AZ, followed by the failure potentially of an entire region. So what you can see here is that we end up with service A being deployed to many clusters. So in the case of an outage of cluster A1, we can just route the traffic for service A to instead cluster B1. So in this case, in this model, our service owners are responsible for choosing to deploy to n plus 2 clusters so that we can deal with the failure of a cluster being drained of traffic for maintenance, but still end up serving traffic successfully. And we also, again, had to build in carrots to this. Go, okay, there's extra overhead for you here. We need to improve our observability so that you know where your service is running, because it's running in multiple places now, not just a single place. It therefore might have issues in a single place. But also for developers, this allowed them to have greater control over how they rolled out a service change, whether it's a new version of a service or a configuration change. So they could roll it out to a single cluster in a given region, and therefore not potentially bring their service down for the entire region by doing so. That's where we are today. We do want to iterate on this model. I would say that one of the reasons that this model is actually possible for us, because we've reintroduced a lot of that increased overhead that I mentioned in the cluster per team model, albeit we're using Amazon managed services, so we don't have to worry about the control plane cost. We've still got service A running in multiple places. So we make use of AWS's Spot offerings to basically allow us to financially place a service in multiple places. But it works for us. However, the future is where some of the problems lie. So I'm not saying I have an answer to these problems, just what we are seeing in Skyscanner. And in other companies I talk to throughout the community. So one of the problems is we've adopted all these cloud native technologies, all of the hype stuff, service mesh, etc. However, the Cambrian explosion is what we're seeing. there's a huge number of different companies and different open source projects here trying different approaches to solving a lot of the problems that cloud native technology has brought. For anyone who has previously seen this before, this is cloud native landscape. These are all of the technologies and companies solving different problems here. Yeah, I mean, there's a pile of observability solutions, there's a pile of container orchestration solutions. It's just endless. And you as a developer looking at that going, oh, I want an observability thing. What do I pick? How are you supposed to know? What's actually the best here? Do you just go, oh, GitHub stars? That's apparently what this landscape is sort of steering you to. If it's a commercial company, they're going, oh, this company's raised more funding than this one, so must be better. Not sure about that. But yeah, to cut it short, too much is being asked of developers. Developers should be focused on delivering value to your end users, whether, in our case, whether it's travelers, whether it's people trying to do their banking, whatever it is. They shouldn't be trying to go through that landscape and figure out, oh, I need an observability function, product to solve this for me. But even if we're only talking about the complexity of running and debugging your application on top of container orchestration platforms like Kubernetes, knowing all of the aspects, let alone layering all of the add-ons that you need for a working cluster, whether it's DNS, whether it's service mesh, etc., keeping on top of that is impossible for a developer even focused in that area. And the leaky abstraction provided by thin platforms sort of add to this. So this is an example of just some of the spec in a Kubernetes pod that if a developer was needing to write that YAML themselves, they would need to consider. So we've got like active deadline seconds, the DNS policy for their pod. Most developers don't want to have to consider that, and rightly so. But equally too much is also being asked of platform teams, because our developers are having to look at that and go, I don't understand this. Or their application is running on the platform and it's not behaving the way that they expected it to, maybe because it's getting CPU throttled. So they end up having to come to the platform teams to ask them to help them understand what their application is doing or why it's misbehaving. And depending on your platform team size, they might be running and providing 20 plus components to provide just a functional Kubernetes experience to their users. So harking back to that CNCF landscape, they might be managing an entire observability stack, whether it's Prometheus, Thanos, Cortex, whatever. DNS, maybe a service mesh, maybe something to provide secure access to the resources in that cluster. And all of this is on top of the upgrades to Kubernetes itself every 4 months or so. And that's a constant toil that currently has no end. And all of those potentially breaking changes that can make to everything in the stack underneath. So for instance, at the moment, my team is focused on moving from Docker as the container runtime to Containerd. And turns out for most services, works just fine. We've got one node service where it turns out it doesn't work, and we're having to help that team sit there and debug, okay, what functionality are you using? Because it's not the Docker socket, it's not anything of the usual suspects that we already looked for. Why is this not behaving the way we want? But they also have to be those subject matter experts when an application isn't running the way it's expected to. And finally, if they're not using a managed service, for either because they don't want to or because they can't for container orchestration, they also have to be responsible for scaling up and down the control plane to sort of fulfill that promise of the cloud of responsive spend in response to demand. So those are the problems. I think the solution for companies of Skyscanner scale is actually moving towards thicker platforms and also developer portals. The slightly hot term for this at the moment is platform engineering, which seems to be just thrown around as an excuse to say that DevOps engineers should be given even more money. But newer companies without significant technical debt have a significant advantage here. So if you look at a newer company like Monzo, so Challenger Bank, digital native, They've built all their microservices in a single language, single framework, into a monolith, allowing them to far more easily encode best practices to all of their applications. If they discover an issue with one of their libraries, they can update it across their entire fleet for all services in one. This is obviously far more difficult for companies where you might have a variety of languages, you might have people running different Java frameworks, etc. But moving towards that more standardized technical stack makes it far easier for you to encode best practice and share best practice across different applications. The other thing in this space is developer portals have begun to explode, aiming to allow platform teams to surface important information in a far more easily consumable and consistent manner across an organization. So if we look at things like the talks this morning, where we've got, you want to surface some FinOps information to your service owner, say how much is your service costing to run this month versus last month, but you maybe also want to expose some SecOps or DevSecOps, like here's how many CVEs you are, and maybe even prioritize them for a service team to go, I have X hours of SRE work or engineering health work a week. Which do I prioritize out of these many, many things that are being shared from across the org? So this is just an example. This is Backstage. It's an open source extensible developer portal from Spotify, but there's a number of other offerings in this space, including managed offerings. So what you can see here is a number of different services with their service type exposed. This is all pluggable, so effectively you can encode it as your org chooses to, share the information, and this is, for instance, their Kubernetes integration. This is part of the core Backstage experience, but it can show you your service's health. So for a company like Skyscanner, where we have potentially a single team owning services which are deployed to different clusters, we could easily expose, okay, that service is currently running in these 4 clusters, actually it's unhealthy in this cluster, and then potentially click through to a unified experience of what your logs are like or what your metrics are there. The other thing I think is coming is long-term support. Kubernetes is certainly, I think, time is a circle, and it turns out that people have realized that actually fast releases repeatedly of your infrastructure software becomes a pain, and the community has spoken on this. Kubernetes has started looking at long-term support again. They're talking about 2-year support, a long-term support release, and also GitOps for everything. So it's already been adopted largely for services. So tools like Argo CD and Flux are making that fairly easy for service teams to do on Kubernetes. However, things like infrastructure, so infrastructure as code has been around for a long time. We've got CloudFormation, Terraform, a number of different tools in this space. However, a lot of them are still quite imperative, and you can end up with drift between your desired state and what is running in production. So you have a disaster, you go to redeploy it, and you go, oh, that stack is now 2 years out of date because I kept on clicking on things on the console to solve problems. I was hitting limits, so I scaled it up. There are now tools looking at GitOps in infrastructure as well, so that your desired state in Git should always be what's being reconciled to try and address that. Yeah, thanks.
I love these surprise endings. Emily Shea is Head of Application Integration at GTM AWS, and Emily's going to be talking about how you go about building innovative architectures. So, Emily.
Wonderful. Thank you so much. Thanks, everybody. I'm super excited to be wrapping up what's been an excellent conference with one of my very favorite topics, talking all about building event-driven architectures on AWS. So a little bit about me. I'm from Seattle, but I live down in London now. I've been there for about 2.5 years. And I never miss an opportunity to come up to Edinburgh, especially on a gorgeous day like today. This is truly the best I've ever seen it, and I will absolutely be coming back because this is amazing. But love living in London and getting to be out here. I've spent most of my career at AWS working in serverless and integration services, working on go-to-market strategies in my day job. And then outside of work, I'm also a self-taught developer. So I love kind of building my own applications and getting hands-on with stuff. in kind of my free time and building my own stuff. Currently, my role at AWS is leading the global go-to-market strategy for application integration services. So a bunch of the services that I'm going to get into today that you can use to build event-driven architectures. So event-driven architectures are definitely a kind of trending topic at the moment. If you got a chance to watch Werner Vogel's, the Amazon CTO at reInvent last year, his keynote was phenomenal and talked a ton about how a lot of AWS and Amazon is kind of internally built around this concept of event-driven and asynchronous for scale. And we're really seeing that it resonates and is working super well for a lot of our customers as they're building larger and larger applications in the cloud and having more and more of these development teams that need to contribute to those applications. Building around events has been a really nice way for them to be able to scale those out and to be able to move really quickly. So basically in this talk today, I'm going to take us through the definition of EDA. I'm going to talk a bit about some of the things that some of the AWS customers that I work with are building. And then lastly, I'm going to show you some of the services and the patterns that you can use to build event-driven architectures yourself. So first off, just defining what is an event. An event is any kind of change in state or an update within an application. So this could be something like maybe a change in your infrastructure that you need to scale up for, or a security event that you need to react to. Or it could be more of a business event. Maybe a user places something that they want to buy in a cart on an e-commerce application, or someone submits a file that you need to process. Any of those can be events, and there's events that are kind of typical of all these different industries that you can see. And event-driven architecture is when we're building an application around events, and we're using those events as the communication mechanism for all the different microservices and services within an application, and also for the individual development teams. So when they're building and interacting with another team that's building another microservice, they're using events to communicate between the two. So that's a little bit of an introduction of kind of what is event-driven architectures and then the definition behind it. Now I wanted to get into a little bit of why you would want to build event-driven architectures and some of the core benefits behind them. So the first one is really about unlocking a lot of developer agility and then also extensibility of those applications. Oh, am I too far away? Better now? Awesome. All right. Talking about developer agility and extensibility. So as you're building a microservice application, you're probably going to have lots of these different services that come into play. So for example, an e-commerce application might have an order service, an inventory service, a search service, all these services that need to interact. Now, a typical application is going to look like this, where you're building loads of kind of point-to-point connections between those microservices, and can quickly become a big spaghetti wall of lots of different microservices that need to be aware of lots of details about one another. What this can mean when you're trying to launch a change to one of those microservices is that you first need to communicate with all those different teams that are building those other microservices and make sure that you're not going to impact them, or you're not going to have a change that then causes a failure in their system, need to know the behavior of maybe their APIs or how their system is going to react to the change that you're going to make. And overall, that just really slows things down and means that all the developers are kind of stepping on one of those toes rather than just releasing the features that they want to be building. With a event-driven architecture, you instead kind of take that apart and detangle that just ball of spaghetti, and now you've got a central event broker. And the cool thing about this is that all of those microservices, they only need to be aware of the event broker and the kind of format of the event that you're sending to it, or the event schema. They don't need to know all the behavior, all the intricacies of the other team's microservices. And this reduces the complexity a lot for them as they're kind of building and being able to make new changes to their microservice, and allows them to move a lot faster without feeling like they're needing to negotiate with a lot of other teams in order to get their change done. Another really cool thing about this is that you've already got loads of kind of events flowing throughout the system, and you can super easily pick up one of those events and build a new service or build a new feature on top of it without making any changes to the existing application. So it's a really nice way to kind of take the existing events and existing kind of data that's running through the application and build new things on top of it without needing to touch or make any changes to what everyone else has already built and is already existing. So a pretty cool example of this is one of our customers, Taco Bell. So during the pandemic, they had loads of demand for lots of new delivery partners, all these different kind of delivery drivers and applications that are now giving you the ability to order online. What the challenge was is that they needed to have a way to get those delivery app orders onto their point of sale system. They had a system where it was like give the in-store employee a tablet, and then they have to manually do data entry and copy it over to the point of sale. And it was just a really kind of broken process, and it was slowing everything down within the store operations. So they needed to super quickly put something together where they were going to take these order events coming off of the delivery apps and funnel them over to the point of sale system. So they were able to build this super quickly. They developed a proof of concept in just, is that 2 weeks? Yes, 2 weeks. And then we're in production in 2 months. And quickly were able to add on a bunch of new delivery partners, a bunch of those additional delivery apps that they were working with. So just the extensibility of being able to build things super quickly with events was definitely helpful for them as they need to react to this big change in demand in the market. The next benefit that I want to talk about is building with events allows you to have increased scalability and fault tolerance of your applications. So a typical application is probably going to have synchronous calls to downstream services. And a synchronous call is one where somebody makes a call and they expect a response from that downstream service. So they're waiting for that downstream service to say, yep, I got your message, and to send them back a response. Now, this works well until something fails in the downstream. Then that failure is cascading, and all the other services are impacted by the one failure that had a problem, or the one service that had a problem. Now, with an event-driven system, an asynchronous system, the upstream service is making a call downstream, but it's not sitting around waiting for a response. It shoots that event off and knows that whatever is going to process it downstream is going to do that on its own, and it doesn't need to worry about it. And so what this can do is it allows your microservices to be able to fail very gracefully. They're not going to be a single point of failure for the entire application. You can handle that failure within the microservice and kind of limit the blast radius of what could possibly go wrong within the application. One of our customers that has kind of taken this approach in their whole architecture is Lego, which I know based on the booths upstairs, we're all big Lego fans, which is awesome. So they had a problem where back in 2017 on Black Friday, they had a single database that had an issue and became a single point of failure for the entire application. So it brought the whole thing down and it had some serious problems for their entire application. So they took that learning and said, okay, we're going to kind of decouple this and build this entirely as an event-driven architecture with microservices that are communicating asynchronously. So now this is the back end of their e-commerce site. All the different kind of microservices are decoupled and communicating via events, and they're able to scale up tremendously for those massive peaks that they have around Black Friday or other big sales. So the last benefit that I want to touch on is just the overall lower total cost of operations that you can find with building event-driven architectures, but then also with taking some AWS serverless services that are super well suited for event-driven architectures and applying those to your application. So serverless services, I'm talking about some of the things like AWS Lambda for event-driven compute, EventBridge, and step functions. Some of these are really designed around an event-driven model, where they're only operating when there's an event for them to process. They're able to auto-scale up and scale down based on the volume of events. And they also have a lot of kind of native integrations for working with events that mean that you don't have to kind of write custom code to be able to handle events or to do retry logic when your events aren't being processed correctly. This really allows you to focus on the business logic rather than a lot of infrastructure management. And then also there's a huge total cost of operations benefit to be had if you have a really spiky workload. So if you're kind of thinking about buying a server or a virtual machine, you're always paying for the same amount of capacity, no matter if your usage is kind of going up and down throughout. And so we find that for customers that have super spiky workloads and very unpredictable workloads, it can be super nice for them to rely on serverless services and not need to plan or do any kind of upfront planning for all of the scale that they might need to handle. You're going to go join them afterwards because it sounds like a party. So here's a couple of the customers that have seen a ton of benefit from being able to move to these kind of architecture patterns, seeing some really significant cost reductions in the amount of kind of expense that it takes to run their infrastructure. Thank you very much. Okay, so talked a bit about definition of event-driven architectures, kind of benefits of them. Now I wanted to get into some of the ideas to help you as you're thinking about, okay, how would I go about implementing this myself? We have a bunch of different, kind of a whole suite of services that a lot of people find useful for building their event-driven architectures. Things like Amazon EventBridge, which allows you to set up event buses for filtering and routing events. Amazon Simple Notification Service, our PubSub messaging service that allows you to send notifications via text message or email, or for fanning out to a number of different consumers if you need to broadcast an event out. Lambda I mentioned, which is our event-driven compute service. We also have Kinesis data streams if you need to do event streaming, SQS for queues that you need to queue up asynchronous messages, and then also step functions for allowing you to orchestrate your event flow and build workflows around it. I think I found a lot of people when I introduced them to kind of the suite of services, they start thinking about, okay, which is the one service that I'm going to use for my entire event-driven architecture and that's going to kind of be the center of it. But I really encourage people to instead think about, okay, how are you going to kind of take each of these purpose-built services and combine them into patterns and use that as kind of a starting point to work backwards from this is my use case, this is what my application needs to get done. These are the patterns of multiple services coming together that I'll use to kind of compose this larger application. So I've got a couple examples of these. Really the 6 patterns that I find are the most common in a lot of the applications that I run into, to just give you some ideas of how you might be able to implement event-driven within your own systems. So we're going to talk about both sides, the both event producer side of things and the event consumers. And all of these are kind of sitting around that central event bus. That is what all of the microservices need to be aware of. So first off, starting on the event producer side. And quick note about this is, so I've got all of these patterns, they're all serverless land patterns, so they're deployable with infrastructure as code. You can find the templates are open source. I've got a link out at the end to a GitHub repo that pulls all of them in together, but just to note that you can find all of these patterns on serverless land. So the first patterns that's super common is just taking user input and converting that into an event that then the system can process. So maybe an API call, maybe it's like somebody putting an order in their cart, is then hits an API gateway. You might have a Lambda function or some compute that translates that event into something that gets put on the event bus, and then the rest of the system can react and need to handle shipping or billing or whatever it is that needs to be done to make that take that order event and be able to ship that out to whoever was purchasing it. Another really common pattern that we see is customers that want to take events from their SaaS applications. This could be Salesforce or GitHub or Shopify or any of these SaaS applications that they're using for different parts of their application. And they want to take those and they want to take some action on them and pull them into the AWS cloud. And so we have direct integrations with Salesforce and a bunch of these to allow them to kind of pull those in directly and be able to take action on them. Another one is around event streaming. So a lot of people are using Kinesis or Kafka and are interested in how kind of event streaming fits in with some of the event routing and filtering that we do with event buses. A really common one is to think about like just really massive amounts of events. So maybe it's clickstream data or it's credit card transactions. And there's loads of events flowing in that you want to both be able to run kind of aggregate analysis on, so stream analysis of all these events together. But then maybe you also want to pull out individual events that are meaningful that you need to take action on. Maybe there's fraud detected in one of the credit card transactions. You want to be able to remediate that. You can kind of pull that event out of the event stream with a filter, something like Lambda, or EventBridge has a feature called pipes that can pull directly from that stream. And then that pulls that onto the event bus, and you can take some specific action on one particular event. So that's the three kind of top event producers that we see. I also wanted to move on to the event consumer side of things. So what do you do once you have events coming onto the event bus and you want to be able to process those? First off, so you might have some event consumers that maybe they can scale, but maybe they can't scale quite as quickly as you need to for the event volume that's coming in. Something that's going to be really handy is putting a queue in front of that event consumer so that whatever it is on the other side, whether it's a Lambda function or a container, is able to process those events as it kind of scales up and isn't overwhelmed by those events as they're coming in. Another really common setup that we see is having an event come off of an event bus and trigger a workflow. So with a workflow, you're able to really closely coordinate what are the steps that I'm going to take to process this event. So if you want to take step 1 and then maybe have a choice state of if the event looks like this, go this route. If it looks like this, go this route. Then you're able to kind of carefully coordinate those different steps that take place within the workflow. And so a workflow service like step functions can be super helpful for having a very closely kind of organized order of processing the event, and then be able to take a new event and put it back on the event bus once whatever task it was is completed. The last pattern that I want to talk about is user notifications. So as you have all of these kind of asynchronous processes that are happening on the back end, you want to make sure that you're informing the users and telling them how things are progressing and giving them updates on the status of whatever it is that they're waiting for. So you can use a notification service, maybe something like a Lambda function that sends out events either via WebSockets with something like IoT Core, or via SNS if you want to send maybe text messages or push notifications, just letting the user know that, hey, this is kind of the stage of the process that we're at, and keeping them updated on what's happening on the back end. So lastly, I wanted to take an example of how we might pull all of these patterns together. So think about something like a insurance claims application. We've got a couple different things that we need this application to do, kind of the business use case or the problem that we're trying to solve with it. We want to have the ability for users to sign up and to submit their documentation, maybe to submit their driver's license or maybe photos of an accident if they want to file an insurance claim. And we want to have a backend that's able to process those documents, maybe run some AI/ML on them to understand and kind of validate if they're for real. We want to be able to handle new user sign up and new claims creation. And then lastly, of course, we want to be able to send notifications to the users just so that they can be updated on the status of their account and the status of their claim. So here's how we might pull in all the different patterns, or a handful of different patterns that I've talked about into the application to be able to build this around this use case. We might use the user input event to allow people to sign up and to allow them to submit claims. We might have a document service, which takes a new document uploaded event and goes through a number of steps. Maybe that's sending it to TextRack to do some analysis of what the text is in that document and be able to process the document in that way. Then we've got our backend with our user service and our claim service. And the cool thing about these is that you can really kind of be flexible on the type of compute that you choose for these services. It could be a serverless Lambda function, or it could be a container. But either way, you've got that queue set up in front so that you're not going to overwhelm it if you have a natural disaster. There's a huge volume of insurance claims that are coming in. Those downstream services are still going to be able to kind of process things as they scale up. And then lastly, the email updates out to users so as to be able to send them notifications about how their claim is progressing. So this is a really cool kind of end-to-end application and example of how you might pull all these patterns together to build an event-driven architecture. This is actually kind of a fully working code sample that we have out online, and one of my colleagues just did a recent presentation online, so you can kind of see the whole walkthrough of the application. So I've got some links out to the blog series and also the GitHub repo, so you can kind of check it out and understand a little bit how it works behind the scenes. I wanted to touch on the two patterns that I did not mention in the application. And for this reason, there's plenty of patterns that you might not need in every single application, but there's definitely going to be a use case where you might pull that pattern in. So it could easily, maybe you have your some CRM information within something like Salesforce. You could pull those events into the application with that type of event. Or maybe you want to do some event streaming. Maybe you want to have a usage-based insurance plan where you're pulling in IoT data about how the user is driving, and you want to be able to kind of assess and adjust their insurance plan based on that data. Then that would be a great use case to pull in something like event streaming and then pull those events in for stream analysis. So wanted to wrap up with a couple takeaways, just kind of covering this whole topic of event-driven architectures on AWS. The first off is that an event-driven architecture is just really built around events with systems and development teams using events as the primary kind of vessel for communication. With event-driven architectures, you get enhanced developer agility and extensibility of applications, also scalability and fault tolerance benefits, and then lastly, a lower total cost of ownership in many cases. Serverless services provide a ton of benefits and are really uniquely compatible with the event-driven model. And you're probably going to be combining multiple purpose-built services into a pattern when you're thinking about your kind of event-driven architecture use case and how you want to build that application. A couple of resources if you want to learn more, and I've also got this whole GitHub repo with kind of all of the patterns, all of the deployable code samples, and a couple of the ways that you can learn a little bit more around EDA and then also serverless on AWS. Thank you very much.
Thank you. Thanks very much, Emily. Now, we still have Slido operating, or we can still do it old school if you prefer. If you've got any questions of our three panelists, please. Gentlemen there, can we get a microphone? Just keep your hand up, please, sir. They're not very quick. There we go. Just identify yourself too, please.
So, Neil Campbell from Exception. It's a question for Emily. We've just recently delivered a solution very like that, event-driven in AWS. And one of the sort of advantages we found was that the lower the kind of maturity of the customer was, the sort of later new requirements were starting to appear. And having that type of architecture really helped us in being able to evolve it as the solution was being built. Do you find that's common across customers?
Absolutely. I think anytime that you're building a modern application, the pace of development just needs to be so fast, and there's so many kind of changing requirements, and the end user demands are constantly increasing. And so setting yourself up with an architecture that is able to evolve super quickly and that is able to kind of grow as the business grows can be super impactful. And so that's really cool to see that you've already kind of experienced that yourself.
The question here on Slido, and to be honest, if we had £1 for every time a variant of this question has been asked, we'd have 14 quid. It says, given the huge variety of different products and providers, where is the best place, stroke source, for organisations to go for an impartial steer on what to choose? I'm going to start with you, Alex. There isn't really any winner,
whoever can answer this question will make a lot of money. Yeah. I don't think there is like a place where you can go for an impartial steer. Like, I think any conference, any event you attend, people will say, buy my product because it's better or it's best. I do think that before you do go for one product or one platform or one vendor, take some time. Talk to the people that will be building things. Ask them what they want to see from the product. Ask them what they need. And then go and tell all those people that are coming to pitch to you that their product is best. Show me where you've done that thing that I need with someone else and that is successful. Because if they tell you, oh, we're really good, we have all these things, okay, great, but this is my problem, this is what my teams need. Show me where you've done it before. And if they don't have a good answer, or if they give you the, yeah, we can't really share that information, just don't go with them. Like, they can like, make information confidential, and like take out things, take out numbers, take out names. They can still demonstrate to you how they've done it and how well it works and how well it's performed. So don't do it. If they can't demonstrate to you that what you need they've done before and they're really good, don't do it. Go and find someone else. Go and find 5 other people and ask them, can you do this, or can you help me do this? And if they can't, they're not the person for you.
Guy, you are nodding your head on that.
I think a lot of this stuff I implement is open source solutions, so it's generally less vendors pitching to you and more a pile of GitHub repos over promising. So I think in that case, a lot of it is building a network of people at similar size companies in the industry and talking to them about whether they're seeing the same problems. If they are, like what solutions have they maybe tried and backed out, or have they tried what the technologies you're looking at? So that's an approach that we have taken and continue to take when we're sort of looking at and evaluating onboarding new open source solutions to our problems. And in our case, talking to vendors like AWS and saying, are you seeing other customers with the same problems here? Are you able to connect us with customers, even ones that may not be in the same geographic region to you, so you may not have a natural connection to them? Often your vendors are willing to connect you just to build goodwill.
Okay. Is it a bit like buying a car, Emily? At the moment, essentially you're looking at a whole series of pretty similar metal boxes in a dazzling array of grey at the moment. But how do people actually go about choosing? Is it word of mouth? Their pal has it, the most expensive one, shiniest, biggest name. What is it?
I do think that the recommendations from Guy and Alex about kind of looking at examples within your industry of who's having success and what are they adopting, I think that can be super helpful. I also know that there's a ton of phenomenal consulting partners upstairs that that's their specialization day in and day out. And so if you're really looking for somebody that's kind of done it a bunch of times before and has had that kind of hands-on experience of helping other customers kind of get up to speed on a lot of things, I think they can provide phenomenal resources to just kind of draw on their vast experience.
While we've got you on the microphone, question there. Can you give examples of what are the disadvantages of event-driven architecture?
Yes, absolutely. So I think one really interesting thing to think about, so Gregor Hope is one of our kind of senior strategists at AWS, and he always talks about how kind of the degree of decoupling of two systems that you want to shoot for is more decoupling is better when you have less control of the kind of two different endpoints or two different services that you're working with. And basically what that means for me is that if there's a single development team that's building both microservices and has a ton of control over them and is able to kind of carefully say, okay, we're going to make a change in this one, let's also make sure that we kind of compensate for that in the other one, and you have a ton of control of those two systems, then it probably doesn't make sense for you to kind of spend a ton of time making those super decoupled and super kind of asynchronous in the way that they communicate. But if you're one team within a vast organization that you have loads of other teams that you need to work with, they've all got their own microservices, it's super hard to get a hold of them and to be able to kind of understand details of their systems, that's when it's probably better for you to have kind of a standard asynchronous way of communicating like events, just because you have so much complexity within the organization to solve otherwise. And so I think that's kind of an example that comes to mind for me of when I might not gravitate towards something like event-driven architectures.
Okay, any other question from the floor? Lady at the front here, please.
Emily, this is a follow-up question for you. I'm Priya. I'm from WNS Wurim. So how does change management happen in an EDA-driven architecture?
Change management in terms of like when you want to evolve an event?
Mm-hmm.
Yeah, absolutely. So I think that's something that it is super helpful to have something like a CCOE for that is able to set kind of some of those best practices around here's what goes into an event schema, here's what happens, here's the process for when you want to update an event schema and whether it should be kind of backwards compatible for things that used to be in the event that you're sending out to the rest of the services that need it. I think that's an area where it does help to have a little bit of kind of a centralized approach to making sure that everyone's kind of playing by the same rules and has the same set of templates for events in mind. And so I think that something like a CCOE is really helpful for setting up something that allows the events and the application to evolve in a way that doesn't create breaking changes for anyone.
This is industrial psychology, I suppose, but there's an anonymous question there, Alex. When creating a centre of excellence for anything, not just cloud, how do you go about making those who aren't involved in that centre of excellence from feeling un-excellent?
Very good question.
It's a very good question.
I think, right. I don't really use the CCOE as my title very often. It's not something that I
Why not?
need to, because it doesn't, it means it's part of the organization that I'm from, like, you know, like how Guy might be from software engineering, Emily's from event driven, I'm from the CCOE. We're just a team. We're not like the be all end all, like I said at the beginning. But we do a lot of work. So I use more product adoption lead for when I refer to what I do for public cloud. And the way that we build the community, which is a big part of what we do, we need to have that alliance. If we don't have people wanting to work with us and wanting to do things better together, we aren't doing our job. So if someone feels unexcellent and feels that they're being excluded by us, we're not doing our job. Our job is to get everyone pushing together for the same things, which is a better, stronger cloud strategy and adoption. We do a lot of events. I spend my time, we do this thing called the Cloud Open Forum. We have about 1,000 folks from across the organizations, from across roles that turn up every 2 weeks to talk about certain products we have in public cloud, to talk about, ask questions, poke holes at stuff that people are building. We are the same as everyone else. We're all working towards the same thing. If your cloud center of excellence makes people feel unexcellent because they're not in that organization, they're doing something wrong. I don't lead with, I'm from the CCOE. I lead with, I'm Alex, I work in public cloud, how can I help you? That is it. I'm there to serve the organization and our cloud interests. I am not there to tell people how to do their job. Yes, I have a lot of cloud knowledge. I know what I do. I know how I help people. I know to listen, but it's not my job to make you feel like you should be part of my team because we're all part of the same team.
Can I take it from that statement that you just don't like the term Cloud Centre of Excellence?
It's not that I don't like it. It's just that it's not something that defines me.
Okay. Okay.
So I think sometimes, and that's why I started with, people think the CCOE is like Yoda. We're not. We're there to support the Alliance. We're there to make everyone else's job easier. So I think like that's the thing. It's like, that's why I don't lead with it, because everyone has a different reaction. Some people are like, no, those people. So like, I don't want to start with that because it can create some discrepancy between what we're trying to achieve and what people actually think you're trying to do. People think you're trying to come and tell them how to do their job. You're not. You're trying to listen to them to understand how you can make everyone's job easier. So.
You've referenced Yoda a few times.
Yes.
Culturally, we're going right down the rabbit hole here. So did anyone else hear Bill and Ted saying, "Most done, excellent guitar riff"? Thank you for that, anonymous, whoever you are.
Yes.
Hang your head in shame.
Highly upvoted.
There's a good question there too for Guy. What tends to be the decision factors for choosing a vendor-supported product over an open source solution?
Total cost of ownership is the big one. Certainly there are ones where in the past, and it becomes a constant reevaluation. So in the past, Skyscanner has adopted open source solutions for certain things, and then eventually a vendor has matured to the point, or we have reached the point of scale with it that so for instance, Kubernetes, we were running our own clusters deployed by COPS on top of AWS for a long time, and then we hit a certain point of going EKS, Amazon's managed control plane offering, has reached a point of maturity and of cost where it would be significantly cheaper, but also we would remove a lot of overhead. For other things, so observability, for instance, we were looking at things like total cost of ownership, the amount of data flowing through that we were anticipating flowing through our monitoring systems, talking to vendors, going, okay, so what would you be charging us for that amount of data, looking at what the AWS infrastructure we would need to support, doing that ourselves through the open source technologies, and then evaluating. I think the other thing that we often look at is avoiding vendor lock-in. So particularly when we're looking at an open source solution versus a managed vendor, we will always be looking at is this a vendor that's using open standards? So for instance, for things like monitoring now, open telemetry is increasingly adopted by different monitoring solutions. So we could sign a contract in the knowledge that if after 3 years the partner we sign a contract with increases the price, we can take our data, shift the endpoint that we're shifting it to, whether it's an open source or another monitoring vendor, and just ship it elsewhere. So that's the big risk that we're trying to avoid as well.
Okay, thank you. Question from the floor. We've got more questions on Slido. Right, okay, I'll go to one of those. To what degree, I don't know who to address this to be honest, to what degree are AWS EDA tools, stroke technologies compatible with low or no code development? Emily, probably.
Yeah, absolutely. So we actually have some super cool kind of recent innovations in the low and no code space. And I should also preface with the fact that I don't know that we'll ever reach a no-code state of the world. I think that we're always going to be heavily reliant on code and people that can kind of take outputs from cool technology like GitHub Copilot or Amazon Code Whisperer and some of these cool kind of things that help developers generate code and be able to kind of pare them down and use them in the right way. But when I think about kind of the cool low-code innovations that we have at AWS, one of them in the kind of event-driven integration space is Step Function's Workflow Studio. And so what this does is it allows you to kind of drag and drop AWS services into a workflow visually and then output that as infrastructure as code that you can then deploy within kind of the body of your larger infrastructure as code template. And I think this is a really cool way to kind of combine a lot of different AWS services. And then also I feel like workflows are so visual by nature, and the fact that you kind of want to figure out, okay, what steps do we want to take? What are kind of the decision trees that we want to have within this workflow? That it seems like a really nice fit for the ability to have some low-code tooling around it. And so I think we find that we're shifting a little bit from kind of from like just pure code needing to write everything by hand and write all of this retry logic and integration code by ourselves, and moving more towards a world where we can configure that and still have code within the application, maybe spending less time on some of the super manual, super repetitive coding tasks that we might have had in years past.
Okay, thank you. I'm going to put this to Alex. Is complexity and potential bottlenecks, or are complexity and potential bottlenecks, being moved from services to brokers?
It depends. I think like.
Maybe to move
Oh, sorry. So in terms of, basically you're saying that we're now not just looking at deploying a service, we're now looking at using brokers to deploy those services, and then we're moving that decision matrix of what we're going to use to the brokers as opposed to the services. Whoever said it, is that what you're implying or not? Because it's a very generic question. Yes, no, nod? You can just shout yes, we don't need to know who you are.
It wasn't my question, but I would interpret it more being one about the event-driven architectures, where the complexity has moved to the event brokers. Like,
So not brokers as in the humans, brokers as in the, sorry. Yes.
Okay.
Yeah, I can jump in for that one. Yeah, so I think that there is complexity that you are shifting over to the broker when you think about like the event bus or the event broker is the part of the architecture that is doing like the filtering and routing, and you've got rules set up for, okay, this particular consumer is interested in this event. Let's do some filtering and routing to make sure that they get the right events. I think that you are offloading some of that complexity from the microservice, and I think that's a good thing. I think ideally the service is not aware of some of those complex logic and the complex rules that route events from one service to the next. That all does sit within kind of this central event broker, and that allows the team working on the microservice to just fully focus on what their service needs to accomplish and just be waiting for that particular event with that particular schema to come in.
Okay. Anything more from the floor? I thought somebody managed to completely break the anonymity system there. I thought, that's excellent. It was only a matter of time before it was due to happen. Right. And one last question to Alex. How receptive are other departments engaging with the Centre of Excellence? Do they like you?
They do, actually. And I think the benefit of how we've done it, so like with having a semi-centralized model, is the fact that every organization has their own Center of Excellence that's formed of like, I don't know, somewhere between 10, 15 people across that organization that look at different cloud-specific areas. So like things like learning, things like finance, things like architecture. So like each individual organization has their own little cell that is actually their respective CCOE. So it took us a while to get there and like establish who all of those people are in each of the organizations. But we do work really well now. Everyone knows everyone. We have kind of like avenues into the different organizations. They come to us, they tell us what they want to see, what we don't have. They bring back things that they're building that might be helpful to the other organizations. So it takes time, as everything involving humans. But I think like once you build that trust and that relationship between all of the different cells and the alliance, it works really, really well and accelerates super fast. So once you've broken that point of trust, that's like you're really, really going super fast together, not individually.
Can I extend that question
Yes.
right the way down the table? Because I know nothing of your world, but I'm fascinated by communication, always have been. However, you are nice people. However hard you try, I'm going to stand as a non-techie in front of you, knowing that you're trying to make it as simple as you possibly can, so I've got the slightest chance of understanding what you're talking about. That's a real handicap every single time. Guy.
I'll pass that on to you.
Yes, it is. I think there's that's where I think a lot of the like abstracting away things that people don't need to understand, like in our case, developers don't need to understand, like IAM policies, for instance. The majority of our developers don't need to understand IAM policies, so we generally try and abstract it away from them and go, here's a set of golden policies, like guided policies, that if you need access to a Lambda and be able to look at the logs, etc., deploy this, fill in some template blanks. But there will always be bits where we need to do almost one-to-one education where people have specific use cases, and we need to either enable them to understand what they are wanting to achieve and how to achieve it, or potentially, in our case, say, actually, that's not a pattern that we are going to support. Here are alternative ways to do it. Maybe not as efficiently for your team, but for the organization as a whole, it fits better with our best practice. And
your thoughts on this, Emily?
So just to rephrase, recap my understanding, we're talking about how do we as kind of people that are deep in the technology make things understandable for people that maybe aren't spending as much time deep in it as we are?
I think probably my point was more the fact that, you know, people like me are very conscious when we're talking to people like you that you're trying to make it as incredibly simple as you can. And that's a barrier to effective communication, because, you know, essentially it's the equivalent of somebody sitting in a Spanish restaurant and shouting at the waiter. You know, it's that kind of feeling about it. There is a real, we just talk different languages.
Yes, absolutely. I feel like as a fairly recent experience for me in the last 5 or 6 years, I come from very much not within the tech industry. So I've only kind of just recently got into it. I started at Amazon.com on the retail side. And I remember when I first had my conversation with some of the people I was talking to on the AWS side, and they were like, well, Emily, here's a server, and like, this is how this works. And we're just kind of very much like breaking it down from the ground level of like what all these things are. But I still appreciate the fact that I kind of have that perspective of knowing what it feels like to be like taking that first step in and really not having the background or the 10 years of industry experience to be able to ground things in. I feel like it is a huge kind of challenge for us, and like something that I feel like we should hopefully aspire to be, is coming from the technology industry, able to break things down and help people understand them as technology becomes super relevant in everyone's day-to-day life and is front page of the news with all these different kind of advances that are happening. So I think we have a big challenge to kind of make that kind of understandable and bring in concepts and stories and things that people can relate to. But I do think it is something that we're going to kind of grapple with, especially in this generation.
Okay.
I also wanted to add another thing about that. So we're doing we know that we have to explain it as best as we can and as simple as we can to the folks that don't have the background. But at the same time, like, part of our mission is we want to increase our cloud fluency for everyone in the organization. So from leadership, executives, to the people that maybe work in marketing and business. So we are encouraging, at least in our company, we are encouraging anyone who wants to learn about cloud and wants to get maybe like certified at the like practitioner level. We are supporting them. We're organizing like certification training events. We're trying to get everyone to have a common understanding, even if they don't need to use it. We're trying to, like, we're spending the time to try to explain this to you from our perspective, but we also want you to meet us halfway. And if you are interested and you want to know more and you want to know what we're talking about half of the time, you do have the opportunity and like the funding and the support to get there, to like meet us halfway.
There's a lovely Larson cartoon which shows two scientists in white coats standing in front of an absolutely enormous whiteboard, and it is covered from that corner down to that corner in this enormous formula. And he's pointing with a stick and he says, and at this stage a miracle happens. That would be good enough for me. It really would. But can I ask you to thank our last three speakers one more time, please? I'd just like to offer a big thank you to all our speakers today. I'm sure you'll agree they have been excellent. I'd also like to thank our conference partners, the exhibitors and the sponsors, without whom, as Ray said this morning, this simply wouldn't be possible. Most of you are wearing delegate badges. By all means, take them home if you want. I've got a big bowl of them at home, but if you leave them here, Digit will recycle them. Just put them in the registration desk. As Ray said, there's a drinks reception now in the Stratosphere. Stay on and enjoy it if you can. There's a conference survey. I know there's always a conference survey, but they actually take this quite seriously. They go through it, point by point and what have you. And if there's anything you think that could aid or assist or improve future events, they would be delighted to see it, genuinely delighted to see it. Come to that, if you fancy speaking at one of these conferences yourself, or better still, if there's someone sitting next to you who think would make an excellent speaker, by all means, dob them in and let them, just let us know. I'll just mention a couple of upcoming events. Scott Secure West, 14th of September, that's at the Technology and Innovation Centre in Glasgow, and the FinTech Summit, which is here at Dynamic Earth on the 21st of September. If you're going up for the drink reception, may see you there. If you're going home from here, safe journey. From me, Mark Stephen, thanks for your attention. Thank you.